I'm grateful you joined tonight. Your brain erases 95% of your dreams within minutes of waking. Yet some people remember vivid details every morning. You'll discover why your mind selectively forgets most dreams and understand how to unlock the memories your sleeping brain tries to hide. Welcome to Get Sleepy Science. Wherever you are right now, perhaps wondering about dreams that slipped away this morning, or feeling curious about forgotten nighttime journeys, allow yourself this gentle exploration. We'll journey through 100 psychology facts about dream memory, from the brain mechanisms that erase dreams before breakfast, to the sleeping patterns that preserve midnight visions, to bridges between consciousness and the forgetting that protects your waking mind. This thoughtful journey through consciousness builds bridges between searching minds. A soft subscribe, like or sharing your thoughts, creates a pathway for more dream seekers to discover and brings us closer to protect this sanctuary. One sleepy soul at a time. Your journey inspires ours. Let yourself settle completely here. Feel your jaw unclench. Your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into peaceful fog of approaching sleep. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Almost everyone dreams multiple times each night. Yet most people remember fewer than one dream per week. According to research published in February 2025 in Communications Psychology, dream recall shows remarkable variability between individuals. The study followed over 200 adults for 4 years and discovered that some people wake almost daily with vivid dream memories, while others struggle to recall a single dream per month. This isn't because some people dream less. Sleep laboratory studies confirm that nearly everyone experiences dreams during approximately 20% of their sleep time. The difference lies not in whether dreams occur, but in whether the sleeping brain successfully transfers those ephemeral experiences into lasting memories. Your brain faces a fascinating challenge each morning, deciding which midnight visions deserve preservation and which should dissolve like morning mist, forgotten before your first conscious thought. Your attitude toward dreams significantly predicts whether you'll remember them upon waking. The same 2025 study revealed that people who value their dreams, who view them as meaningful rather than random neural noise, recall dreams far more frequently than those who dismiss dreaming as unimportant. This relationship isn't simply about paying attention. It reflects something deeper about how your brain prioritizes information. When you believe dreams carry significance, your sleeping mind unconsciously allocates more resources to encoding those experiences into memory. Think of it like photography. If you consider something worth photographing, you'll compose the shot carefully, adjust the lighting, ensure the image captures detail. Your brain does something similar with dreams. When you value them, your neural circuits work harder to preserve them, creating stronger memory traces that survive the chaotic transition from sleep to wakefulness. The transition from sleep to wakefulness presents a neurochemical shift that destroys most dream memories before they fully form. During REM sleep, acetylcholine levels rise significantly, supporting the vivid imagery and emotional texture of dreams. Meanwhile, norepinephrine and serotonin remain at very low levels. Upon waking, this chemistry reverses. Norepinephrine and serotonin increase, while acetylcholine decreases. This abrupt transition disrupts fragile memory consolidation, like pulling power while a file saves. Dreams formed in one neurochemical environment struggle to transfer into the very different chemistry of wakefulness. The dream memory, not yet solidified into long-term storage, simply vanishes. Only memories that successfully transferred to more stable neural networks before this chemical shift survive to reach your conscious awareness upon waking. People who frequently daydream during waking hours remember significantly more dreams than those who maintain constant external focus. The 2025 communication psychology study identified mind wandering, the tendency to shift attention away from immediate tasks toward internal thoughts and imagination, as one of the strongest predictors of dream recall. This connection makes intuitive sense. Both dreaming and daydreaming involve your brain generating internal simulations, relatively independent of immediate sensory input. If your waking mind comfortably wanders through imagined scenarios, your sleeping mind apparently finds it easier to encode and preserve those nighttime wanderings. Think of it as practice. Regular daydreamers have well-developed neural pathways for creating, experiencing, and remembering self-generated mental content. These same pathways remain available during sleep, making dream memories more accessible upon waking. Your age subtly influences how often you remember dreams, though perhaps not in the direction you'd expect. The 4-year study found that older adults recalled slightly fewer dreams than younger participants, but the relationship was surprisingly modest. This age-related decline isn't primarily about memory deterioration. Instead, it reflects changes in sleep architecture. As people age, they tend to experience shorter periods of light sleep and longer stretches of deeper, slow-wave sleep. Since dreams are more easily recalled when awakening from lighter sleep stages, particularly REM sleep, these architectural changes reduce opportunities for dream memories to successfully transfer into consciousness. The content and vividness of dreams themselves don't necessarily diminish with age, just the likelihood of remembering them upon waking. The length of your sleep significantly affects dream recall in predictable ways. People who sleep longer remember more dreams, not simply because longer sleep provides more dreaming time, but because sleep architecture changes across the night. During the first sleep cycle, your brain spends more time in deep, slow-wave sleep with minimal REM periods. But as the night progresses, REM periods lengthen, while deep sleep becomes less prominent. By morning, you're cycling through extended REM phases, sometimes 20 to 30 minutes of near-continuous dreaming. When you wake naturally from these lengthy REM periods, dream memories remain fresh and accessible. Shorter sleep truncates this process, cutting off the lengthy morning REM periods when dreams are most vivid and most easily remembered. The proportion of deep, slow-wave sleep in your nightly rest inversely correlates with dream recall frequency. Research from 2025 showed that individuals with higher percentages of deep N3 sleep reported fewer dream memories than those whose sleep contained more light stages. Deep sleep serves crucial restorative functions, consolidating factual memories, clearing metabolic waste from the brain, supporting immune function. But it's not optimal for dream encoding. During deep sleep, the brain exhibits slow, synchronized oscillations quite different from the faster, more chaotic activity of REM sleep. These slow waves, while beneficial for many cognitive processes. Create an environment less conducive to forming the kind of episodic memories that allow you to recall dream narratives upon waking. Deep sleep prioritizes physical restoration over dream preservation. Seasonal variations influence dream recall in ways researchers are only beginning to understand. The 2025 study documented significantly lower dream recall during winter months compared to spring, suggesting that environmental or circadian factors play subtle roles in dream memory formation. Potential explanations include winter's reduced daylight affecting melatonin regulation, seasonal changes in sleep duration, or temperature-related alterations in sleep quality. Winter sleep tends to be deeper and longer, which paradoxically may reduce dream recall despite providing more total sleep time. Spring's lighter sleep architecture, influenced by increasing daylight and warming temperatures, might create more frequent awakenings from REM sleep, exactly the conditions that favor dream memory preservation. The seasons quietly shape not just what you dream, but whether those dreams survive into morning awareness. Your vulnerability to cognitive interference predicts how well you remember dreams. The 2025 research measured participants' susceptibility to distraction and found that those more easily derailed by competing information recalled fewer dreams upon waking. This makes neurological sense. The early morning period, when dream memories are most fragile, coincides with high vulnerability to interference. If you immediately grab your phone, engage in conversation, or jump into morning routines, these activities flood your working memory with new information, effectively overwriting the delicate dream traces. People resistant to such interference, those who can maintain internal focus despite external demands, better preserve dream memories through the chaotic transition to full wakefulness. Your brain's resistance to distraction acts like a shield protecting vulnerable morning memories. We've explored the first 10 insights into dream memory, and patterns are beginning to emerge. Dream recall isn't random chance, but rather a complex interaction between stable personality traits, sleep architecture, and cognitive abilities. Some people possess natural advantages, valuing dreams, daydreaming frequently, maintaining focus despite distractions. Others face structural challenges, age-related sleep changes, excessive deep sleep, high cognitive interference. But these factors don't operate in isolation. They interact, sometimes amplifying each other, sometimes compensating for one another. A young person who dismisses dreams as meaningless may recall fewer dreams than an older person who treasures them. Understanding these factors reveals something profound. Your relationship with dreams isn't fixed at birth. How you think about dreams, structure your sleep, and manage morning routines all influence whether those midnight visions survive into conscious memory. Recent discoveries about REM sleep have revolutionized understanding of how dreams embed into memory. Research published in 2024 in Science Advances revealed that REM sleep performs a critical recalibration of neural activity, essentially resetting brain excitability to optimal levels for new learning. This recalibration process doesn't just support memory consolidation generally, it specifically modulates how hippocampal and neocortical regions communicate. The extent of this REM recalibration predicts which memories persist and which fade. Dreams occurring during these recalibration windows may become embedded more deeply in memory networks, surviving the transition to wakefulness. REM sleep. long mysterious in its purpose, appears to fine-tune the very neural systems that determine whether dreams become lasting memories. The specific timing of when you wake within a sleep cycle dramatically affects dream recall. Waking directly from REM sleep yields vivid, detailed dream memories in 80 to 90% of awakenings. But waking from deep, slow-wave sleep produces dream reports in only 5 to 10% of cases. This enormous difference reflects both the nature of mental activity during different sleep stages and the state of brain chemistry at the moment of awakening. REM awakenings catch dreams fresh and recent, with the neurochemical environment still favoring memory encoding. Deep sleep awakenings, by contrast, occur during a very different brain state, one that actively suppresses the kind of narrative, episodic memories that dreams represent. Your sleeping brain processes approximately 4 to 5 discrete dreams each night, though you'll likely remember at most 1 or 2. These multiple dreams don't occur randomly. They follow your sleep cycle structure. The first REM period, arriving about 90 minutes after sleep onset, produces brief dreams of 5 to 10 minutes. These early dreams are easily forgotten. They occur when you're deeply asleep with hours remaining before morning. But as the night progresses, REM periods lengthen. By early morning, single REM episodes can last 20 to 30 minutes, producing elaborate, narratively complex dreams. Most people who remember dreams recall only these final morning dreams, not because earlier dreams didn't occur, but because sleep depth and timing conspire against their preservation. The forgotten dreams still happened. You simply possess no memory of their existence. Dream content itself influences how well you remember it upon waking. Research from 2024 at UC Irvine discovered that people who reported dreaming showed enhanced emotional memory processing the following day. Emotionally charged dreams, whether pleasant or disturbing, create stronger memory traces than neutral, mundane dreams. This seems to reflect evolutionary wisdom. Emotions quietly flag experiences as worthy of preservation. A dream about flying through cosmic nebulae or confronting childhood fears carries more emotional weight than dreaming about organizing office supplies. Your brain, even during sleep, prioritizes emotionally salient content. The same neural systems that help you remember emotionally significant waking events also make emotionally intense dreams more likely to persist into conscious awareness. The relationship between dreaming and emotional regulation reveals why some dream memories persist while others vanish. The 2024 UC Irvine study found that people reporting more positive dreams rated negative images less intensely the following day, suggesting dreams help process and soften emotional experiences. This emotional processing function may influence which dreams your brain preserves. Dreams that successfully process difficult emotions, helping you feel better upon waking, might trigger signals indicating successful processing complete, allowing the dream memory itself to fade. Conversely, unresolved emotional content may keep dream memories accessible, prompting continued waking reflection. Your brain doesn't remember dreams simply as random events, but as part of an ongoing emotional regulation process. Some dreams are meant to be forgotten, their work completed invisibly during sleep. Northwestern University researchers demonstrated in 2024 that targeted sensory cues can enhance dream recall through a technique called targeted lucidity reactivation. Participants who associated specific sounds with lucid dreaming exercises before sleep then heard those sounds during REM periods, showed dramatically improved dream recall upon waking. The technique worked even without full lucidity. Simply the sensory cue during dreaming strengthened memory consolidation. This suggests dream recall isn't purely passive. With appropriate techniques, you can actively influence whether dream memories survive the transition to waking consciousness. The sleeping brain remains responsive to external cues, and these cues can bridge the gap between dreaming and remembering. Sleep's role in forgetting is as important as its role in remembering. A 2025 neuroscience review revealed that specific populations of neurons actively promote forgetting during sleep, clearing space for new learning. Melanin-concentrating hormone neurons in the lateral hypothalamus, particularly active during REM sleep, may selectively eliminate memories deemed less relevant. This forgetting isn't failure, it's adaptive pruning. Your brain can't remember everything. It must prioritize. Most dreams, lacking obvious relevance to waking goals and concerns, fall into the category of expendable memories. The fact that you forget 95% of dreams doesn't represent a deficiency in your memory system. It represents your brain's sophisticated triage process, preserving only information likely to prove useful, discarding the rest to maintain cognitive efficiency. The neurotransmitter acetylcholine plays a starring role in both dream generation and dream amnesia. During REM sleep, acetylcholine levels surge to some of the highest concentrations seen in any brain state. This acetylcholine flood enables the vivid imagery, emotional intensity, and bizarre narrative transformations characteristic of dreams. But upon waking, the sudden return of norepinephrine and serotonin, neurotransmitters largely absent during REM, creates a chemical mismatch that disrupts memory encoding. Dreams formed in one neurochemical environment struggle to transfer into the very different chemistry of wakefulness. Dream memory shows interesting parallels with something called state-dependent learning. Information learned in one brain state is often more accessible when returning to that same state. Since dreams occur during the dramatically different neurochemistry of REM sleep, and recall requires the very different neurochemistry of wakefulness, dreams face a state-dependent retrieval problem. You're essentially trying to remember experiences that occurred in a foreign consciousness state. This state mismatch explains why dreams often feel tantalizingly close, yet frustratingly elusive upon waking. Like trying to remember something on the tip of your tongue. The memory exists somewhere in your neural networks, but the key to accessing it was forged in a different neurochemical reality. Some dreams aren't forgotten so much as temporarily inaccessible, locked behind a state-dependent barrier. The phenomenon of dream lag suggests your sleeping mind processes waking experiences with a strange temporal signature. Research tracking what people dream about relative to their daily experiences finds a puzzling pattern. Recent waking events from the past day sometimes appear in dreams, but there's often a peak of incorporation 5 to 7 days after the original experience. This delayed incorporation suggests a two-stage memory process. Recent experiences quickly access dream content, while events that prove meaningfully relevant to long-term memory undergo deeper processing, re-emerging in dreams days later during memory consolidation. If you remember these delayed incorporation dreams, you're witnessing your brain's extended memory processing timeline. Most dream memories, lacking this deeper significance, never receive this secondary processing and disappear without trace. Lucid dreaming. Knowing you're dreaming while the dream unfolds creates a unique opportunity for enhanced dream recall. Research published in 2025 in the Journal of Neuroscience found that lucid dreams activate brain regions associated with self-awareness and metacognition, particularly in the right temporoparietal junction and prefrontal areas. This increased awareness during the dream itself appears to strengthen memory formation. Lucid dreamers consistently report better dream recall than non-lucid dreamers. Not just for lucid dreams, but for regular dreams as well. The practice of cultivating awareness during dreams seems to enhance the general mechanism by which dream memories form and persist. Lucid dreaming trains your sleeping brain to create stronger, more stable memory traces during the dream experience itself. Interactive dreaming experiments have revealed that dreamers can receive and process information from the external world while remaining asleep. In groundbreaking 2024 research, lucid dreamers answered simple math problems posed by researchers during REM sleep, responding with prearranged eye movement signals. Remarkably, some participants later couldn't remember these interactions, despite responding correctly during sleep. This finding illuminates dream memory's fragility. You can be conscious and responsive during a dream, yet form no lasting memory of the experience. The disconnect between in-dream awareness and subsequent recall suggests dream memory formation requires more than simply conscious experience. Something additional, perhaps specific neurochemical conditions, or particular patterns of neural activity, must occur for dream experiences to survive into waking memory. The sleeping brain's electrical activity patterns predict dream recall success with surprising accuracy. EEG recordings reveal that specific oscillatory signatures during REM sleep correlate with later dream memory. Increased alpha wave activity in posterior brain regions, enhanced connectivity between frontal and posterior areas, and particular patterns of theta oscillations all predict whether someone will remember dreams upon waking. These electrical signatures reflect the coordinated activity of millions of neurons working together to encode experience into memory. When this coordination occurs effectively during dreaming, memories form. When it falters, dreams generate vivid experiences in the moment, but leave no permanent trace. Your sleeping brain's electrical rhythms determine which midnight visions survive to meet morning consciousness. Modern sleep tracking technology, particularly wearable devices, has revealed patterns in dream recall that earlier research missed. The 2025 communication psychology study utilized wrist-worn actigraphy to continuously monitor sleep patterns over 15 days. This extended, naturalistic monitoring revealed night-to-night variability in dream recall that laboratory studies couldn't capture. Some nights naturally favor dream recall, those with longer duration, lighter overall sleep, more REM activity. Other nights suppress dream memory despite normal dreaming occurring. This variability isn't random, but reflects subtle fluctuations in sleep quality, circadian timing, and potentially even factors like stress, diet, and daytime activities. Your dream recall capacity isn't fixed. It fluctuates based on constantly shifting physiological conditions. We've reached the first quarter of our journey, and a pattern has emerged. Dream recall represents a delicate balance between competing neural processes. One system generates vivid experiences during sleep, Another system must encode those experiences into stable memory. A third system must preserve those memories through the neurochemical transition to wakefulness. At each step, most dreams fail to progress to the next stage. They're lost to depth of sleep, weak encoding, interference upon waking, or state-dependent retrieval barriers. The minority of dreams you remember represent successful navigation through this entire gauntlet. Understanding this process reveals that poor dream recall isn't a deficiency. It's the natural outcome of a complex system designed primarily for sleep's restorative functions, with dream memory as an optional byproduct rather than the primary goal. And perhaps that's exactly as it should be. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain thinking, all without your command. Your sleeping brain processes dreams the same way, automatically, below consciousness, organizing midnight visions you'll never remember. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing, working even in sleep to decide what memories deserve preservation. Some dreams are meant to vanish, others wait patiently for morning light. Now we continue. The relationship between stress and dream recall follows a curious pattern. Moderate stress often enhances dream recall, perhaps because stress increases nighttime awakenings and emotional dream content, both factors favoring memory preservation. But severe chronic stress impairs sleep quality generally, suppressing both dream generation and dream recall. The 2025 research found small but significant correlations between trait anxiety and sleep quality, which in turn influenced dream recall. Your emotional state creates a complex ripple effect. Anxiety disrupts sleep architecture, reducing REM sleep duration and quality. But anxiety also increases dream emotional intensity when REM sleep does occur, potentially strengthening the few dream memories that form. Stress simultaneously suppresses and enhances dream recall through competing mechanisms. Sleep inertia, that groggy disorientation upon waking, poses a significant threat to dream memory. During the first minutes after awakening, your brain operates in a transitional state, combining elements of sleep and wakefulness. Cognitive function is impaired, memory encoding is compromised, and attention is fragmented. Dreams recalled during this vulnerable window face immediate interference from waking thoughts and sensations. A 2024 review in Trends in Cognitive Sciences noted that sleep inertia's cognitive deficits hamper accurate memory retrieval and translation, even when dream content might be internally accessible. The groggiest mornings, when sleep inertia is strongest, are precisely when dream memories most easily slip away. That drowsy struggle to remember dreams isn't poor memory. It's your brain still partly asleep. Sleep laboratory research reveals that most dream reports, when carefully analyzed, omit emotional details that clearly occurred during the dream. People describe visual scenes, narrative events, and physical actions, but often fail to fully articulate the emotional texture of their dreams. This emotional underreporting suggests that dream recall involves selective translation. Your waking mind reconstructs dream experiences using words and concepts available to conscious thought. The original dream contained feelings that lack precise verbal equivalents. Some emotional subtlety necessarily gets lost in translation. The dream you remember represents your waking mind's best attempt to capture an experience that occurred in a very different mode of consciousness. What you recall isn't the dream itself, but a waking reconstruction. Targeted memory reactivation during sleep offers new insights into dream memory formation. Northwestern University researchers demonstrated that playing specific sounds during REM sleep, sounds previously associated with learning tasks, can strengthen both task-related memories and dreams, incorporating those elements. Participants improved to an average of 2.11 lucid dreams per week from 0.74. A dramatic increase. The technique works by subtly influencing ongoing dream content through external cues, creating associations that bridge sleeping and waking consciousness. This bridging apparently strengthens the memory trace, allowing dreams to persist into waking awareness. The sleeping brain remains surprisingly responsive to sensory information, and this responsiveness can be harnessed to enhance dream recall. Gender shows subtle relationships with dream recall, though perhaps not in expected ways. While some earlier research suggested women recall dreams more frequently than men, recent large-scale studies find this gender difference disappears when controlling for attitudes toward dreaming. The 2025 study found that female participants showed higher interest in dreams than male participants, on average. When this attitude difference was accounted for, biological sex itself didn't significantly predict dream recall frequency. This suggests cultural factors, expectations about whether dreams matter, whether paying attention to internal experiences is valued, may create apparent gender differences in dream memory. Biology shapes many aspects of sleep and dreaming, but dream recall appears more influenced by psychology. The role of REM sleep in memory consolidation underwent significant revision in recent years. For decades, researchers debated whether REM sleep primarily consolidated emotional memories while non-REM slow-wave sleep handled factual information. New research published in 2025 challenges this clean division. A study in communications biology found that both slow-wave and REM sleep contribute to emotional memory consolidation through different mechanisms. Slow-wave sleep appears to integrate emotional experiences into existing knowledge structures, while REM sleep helps process and regulate the emotional intensity itself. This dual process model suggests dream recall might reflect whether your sleeping brain judges an emotional processing task as complete. Dreams whose emotional work remains unfinished persist into waking memory, demanding continued conscious attention. Successfully processed emotions allow their associated dreams to fade peacefully away. The phenomenon of dream incorporation reveals how external stimuli subtly influence dream content without waking you. Sounds, smells, temperature changes, and tactile sensations sometimes weave into dream narratives. A ringing phone becomes a church bell in your dream. A cold breeze transforms into an Arctic landscape. These incorporations create unique opportunities for dream memory. When external events link to dream content, they provide retrieval cues that can trigger dream recall upon waking. Hearing the same alarm sound that appeared in your dream, feeling the same room temperature, or smelling the same morning coffee might suddenly unlock memories of dreams that would otherwise have vanished. External reality inadvertently bookmarks certain dreams for later recall. False memories can infiltrate dream recall, blurring boundaries between what you actually dreamed and what you believe you dreamed. The process of recalling and narrating dreams involves reconstruction, not playback. Each time you remember and describe a dream, you slightly alter the memory, simplifying some details, embellishing others, filling gaps with plausible confabulation. Over time, the memory of telling the dream can overwrite the memory of the dream itself. Dreams recalled repeatedly, especially those shared with others or written in journals, become increasingly distant from the original experience. What you remember is not the dream, but the memory of the dream, altered through multiple retellings. Memory consolidation during sleep involves selective strengthening and weakening of different memory types. Research from 2024 on sleep-dependent memory processing revealed that the sleeping brain doesn't preserve all memories equally. It enhances memories tagged as important while actively weakening memories deemed irrelevant. Most dreams, lacking obvious significance to waking goals, fall into the irrelevant category. Your brain's overnight triage system efficiently discards them, freeing neural resources for more useful information. This isn't a flaw, but sophisticated memory management. Remembering every dream would clutter consciousness with information lacking practical value. Forgetting most dreams represents evolutionary wisdom. Recent advances in dream science have introduced the concept of dream engineering, deliberately manipulating dream content through techniques ranging from sensory stimulation to lucid dreaming training. A comprehensive 2024 review in Trends in Cognitive Sciences outlined how researchers are developing methods to influence, observe, and even communicate with dreaming individuals. These dream engineering approaches necessarily enhance dream recall. You can't manipulate what you can't remember. Participants in dream engineering studies naturally develop better dream recall as they practice techniques designed to increase awareness during dreams. The more actively you engage with the dreaming process, whether through engineering attempts or simple reflection, the stronger your dream memories become. Engagement during sleep translates to memory persistence upon waking. The sleeping brain's memory replay system, originally discovered for spatial memories in rats, extends to dream content in fascinating ways. During slow-wave sleep, your hippocampus replays recently formed memories, transferring them to neocortical regions for long-term storage. But during REM sleep, this replay takes on stranger characteristics. Memories are reactivated in novel combinations, creating the bizarre scenarios and impossible juxtapositions characteristic of dreams. Dreams that directly incorporate recent waking experiences, the type most likely to be recalled, may represent particularly strong memory replay sessions. These dreams persist because they reflect significant ongoing memory consolidation, work your brain prioritizes. Virtual reality experiences before sleep can influence dream content in surprisingly specific ways. According to research published in 2025 in Neuroscience of Consciousness, participants exposed to immersive VR environments showing cosmic imagery or transcendent experiences later dreamed about similar themes and reported those dreams with unusual clarity. The vividness and emotional intensity of VR apparently creates stronger memory encoding, allowing those experiences to survive into dream content and subsequent waking recall more easily than less engaging stimuli. This finding suggests a principle. The more emotionally and perceptually engaging a waking experience, the more likely it appears in dreams, and the more likely you'll remember those dreams. Mundane daily routines rarely infiltrate dream memory. Unusual, emotionally charged experiences create dreams that persist. The autonomic nervous system, controlling heart rate, breathing, and unconscious bodily functions, may play an unexpected role in dream memory formation. A 2025 review suggested that fluctuations in autonomic activity during REM sleep might influence how strongly dreams embed in memory. Periods of heightened autonomic arousal during dreams, reflected in heart rate variability or skin conductance changes, might tag those dream segments as emotionally significant, prompting stronger memory encoding. Your body's unconscious responses during dreams, the racing heart, the catch in your breath, may determine which dreams your sleeping mind judges worthy of preservation. Sleep's relationship with creativity illuminates dream recall from an unexpected angle. Research shows that REM sleep enhances creative problem-solving, abstract thinking, and novel associations. Dreams represent the ultimate creative exercise. Your brain generating entire worlds from memory fragments, emotions, and random neural activations. People who recall dreams more frequently also tend to score higher on measures of creativity and openness to experience. This relationship likely runs in both directions. Creative minds generate more memorable dreams, while dreams themselves nurture creativity. The dreams you remember represent your brain's most creative nighttime productions. The experience is bizarre, emotionally intense, or meaningfully strange enough to transcend typical dream amnesia. Forgettable dreams exist, but by definition, you don't remember them. We've reached an important junction in understanding dream recall. The evidence reveals that remembering dreams isn't simply about memory, strength, or sleep quality. Instead, dream recall emerges from complex interactions between your attitudes, cognitive style, sleep patterns, and brain chemistry. Some factors you can influence: cultivating interest in dreams, protecting morning moments from distraction, structuring sleep schedules to maximize light sleep and REM periods. Other factors resist easy modification: age-related sleep architecture changes, fundamental aspects of neural chemistry, trait-level cognitive characteristics. But understanding the full system changes how you relate to dream amnesia. When you forget dreams, you're witnessing your brain's sophisticated prioritization system doing exactly what evolution designed it to do: preserving useful information while efficiently discarding most of the night's phantom visions. You're still here, still awake, still drifting with us through these stories. Take a slow breath. Notice how your body feels a little lighter now, as if gravity itself has loosened its grip just slightly. We're thinking through consciousness together, you and I and everyone listening in the quiet dark, exploring memory like explorers charting unknown territory. There's no rush, no destination, just the gentle momentum of curiosity carrying us forward. Let's continue. Simple behavioral strategies can significantly enhance dream recall without requiring extraordinary effort. The most effective technique involves simply pausing upon waking, remaining still, eyes closed, mind quiet, for several minutes before engaging with the external world. This protected pause prevents the flood of waking stimuli from immediately overwriting fragile dream memories. During this stillness, dream fragments often coalesce into more complete narratives. The technique works because it respects dream memory's vulnerability to interference. Morning light, sounds, and movement all compete for your brain's limited attention. By temporarily delaying these demands, you create space for dream memories to solidify. This pause requires discipline, fighting the urge to check your phone, review your schedule, or jump into conversation. But consistently practicing this simple stillness transforms dream recall ability. Writing dreams immediately upon waking creates external memory storage that bypasses biological forgetting. The act of translating dream experiences into words, engaging motor systems to write or type, creates additional memory traces through multiple sensory and motor pathways. Dream journals serve dual purposes. They provide external records independent of your biological memory, and the writing process itself strengthens neural encoding of the dreams you're recording. Over time, keeping a dream journal signals to your sleeping brain that dreams matter, potentially triggering unconscious shifts in how strongly dreams embed in memory. Your brain, learning that dreams receive conscious attention and recording, may gradually allocate more resources to dream memory formation. Consistency matters more than length. Brief daily entries outperform sporadic detailed recordings. The relationship between sleep position and dream recall remains somewhat mysterious. Sleep position might influence blood flow or neural activity patterns, though research hasn't yet established clear connections. More significant is movement frequency. People who shift positions often experience lighter sleep and more brief awakenings, creating natural opportunities for dream recall. Deep stillness promotes uninterrupted rest, but may reduce the awakenings that help preserve dream memories. Your body's nighttime movements subtly shape whether dreams survive into morning consciousness. Very still sleepers, remaining in one position for hours, might sleep more deeply but wake less frequently from REM periods, reducing dream recall opportunities compared to restless sleepers who naturally surface more often. Meditation practice shows robust relationships with both lucid dreaming frequency and general dream recall. Research published in 2024 found that frequent meditators, particularly those practicing meta-awareness techniques, reported significantly more lucid dreams and better overall dream recall than non-meditators. Meditation trains exactly the attention skills useful for dream memory: sustained focus, awareness of mental states, resistance to distraction. These skills transfer to sleep. Meditators may maintain subtle awareness threads during dreams, creating stronger memory encoding. Additionally, meditation's benefits for sleep quality, stress reduction, and emotional regulation all indirectly support dream memory formation. The practice cultivates conditions conducive to remembering dreams, both through direct attention training and through broader effects on consciousness and well-being. Specific supplements and substances influence dream intensity and recall, though often unpredictably. Galantamine, an Alzheimer's medication that increases acetylcholine levels, has been shown in controlled studies to increase lucid dreaming frequency by up to 42% compared to placebo. However, this medication carries side effects and should only be used under medical guidance. Vitamin B6 may enhance dream vividness and recall in some individuals. Melatonin supplements, while promoting sleep onset, can intensify dreams and occasionally trigger nightmares. Natural approaches, protecting sleep, cultivating interest in dreams, practicing awareness, offer safer, more sustainable paths to enhanced dream recall. Chemistry influences dreams, but psychology and behavior matter more for most people. Temperature affects sleep quality and dream recall in subtle but meaningful ways. Cooler bedroom temperatures typically promote deeper, more continuous sleep. But paradoxically, this might reduce dream recall by decreasing nighttime awakenings. Warmer temperatures create lighter, more disrupted sleep, potentially increasing brief awakenings from REM periods. Conditions favoring dream memory. But excessive heat impairs sleep quality generally, overwhelming any recall benefits. The optimal temperature for dream recall likely falls in a narrow range, cool enough for quality sleep, but not so cold that you enter very deep, uninterruptible slumber. Your body's thermal regulation during sleep subtly adjusts the depth and stability of consciousness, influencing which dreams survive to morning. The role of the prefrontal cortex in dream awareness has become clearer through recent neuroimaging studies. This brain region, crucial for self-awareness, logical thinking, and executive control, typically shows reduced activity during normal dreams. This deactivation explains why dreams feel so real in the moment. Your critical thinking and reality monitoring systems are essentially offline. But during lucid dreams, prefrontal areas reactivate while other brain regions remain in dreaming states. This partial prefrontal activation enables the metacognitive awareness characteristic of lucid dreaming, simultaneously experiencing a dream and knowing it's a dream. This awareness strengthens memory encoding dramatically. Lucid dreams are recalled far more reliably than non-lucid dreams, likely because prefrontal reactivation supports the same memory consolidation processes active during waking experiences. Dreams incorporating sensory experiences from multiple modalities: visual, auditory, tactile, emotional, create stronger memories than dreams dominated by single senses. Multisensory integration engages broader neural networks, creating richer encoding and more retrieval pathways. The most memorable dreams often combine vivid imagery with sounds, physical sensations, emotions, and sometimes even smells or tastes. These richly textured dreams activate so many brain regions simultaneously that they leave robust memory traces capable of surviving waking's neurochemical disruption. Conversely, simpler dreams, perhaps just visual snippets or brief emotional moments, lack sufficient neural support for strong memory formation. They vanish like whispers overwhelmed by morning's neural noise. The concept of dream incubation, deliberately focusing on specific topics before sleep to influence dream content, has ancient roots, but modern scientific validation. Research from 2024 on targeted dream incubation devices showed that pre-sleep mental imagery and intention setting can successfully bias dream content toward desired themes. More relevant to recall, dreams successfully incubated through pre-sleep focus are remembered far more often than random dreams. This enhanced recall probably reflects two factors. First, you're primed to notice dream content matching your pre-sleep intentions, making those dreams more salient upon waking. Second, the pre-sleep focus creates expectations and attention that carry into sleep, potentially strengthening encoding of matching dream content. When you actively seek certain dreams, you create conditions favoring memory of those dreams. We've reached the halfway point of our journey. 50 facts explored, 50 remaining. The answer to our opening question is taking shape. You can remember dreams better through combinations of attitude, behavior, and environment. Value dreams as meaningful rather than dismissing them. Cultivate mindfulness and meta-awareness during waking hours. Protect morning moments from distraction, allowing dream memories space to consolidate before external demands intrude. Structure sleep schedules promoting adequate REM sleep. Consider journaling, meditation, or lucid dreaming practice. These approaches work not through single mechanisms, but through multiple pathways. Some strengthening memory encoding during dreams, others protecting memories during the vulnerable waking transition. Still others training general cognitive abilities that transfer to dream recall. The answer isn't a single technique, but an integrated approach. A lifestyle that honors the strange twilight country where consciousness meets sleep. Pause here with me. Notice the present moment. Right now, somewhere in your city, someone is falling asleep. Someone is waking. Someone is dreaming of flying through midnight skies they'll forget before breakfast. Time moves differently in dreams. An entire lifetime can unfold in minutes. Decades compress into moments. But this moment, this breath you're taking now, is shared with all of them. All the sleepers and dreamers and wakers. You exist in the only moment that's real. This one. Whether you remember your dreams or forget them, whether you sleep deeply or lightly, this present moment holds you. Let that awareness settle through you like warm honey. And we continue drifting. The brain's default mode network, typically active during wakeful rest and mind wandering, plays an intriguing role in dreaming. This network, involving medial, prefrontal, and posterior cingulate cortices, activates during dreams, particularly those with strong self-referential content. Dreams about yourself, your concerns, your relationships. Enhanced default mode activity during certain dreams might strengthen memory encoding by linking dream content to existing self-knowledge networks. Dreams fitting easily into your ongoing life narrative may survive better than bizarre, disconnected dreams, precisely because they activate these well-established neural pathways. Your brain preferentially remembers dreams that make sense within the story of who you are. Strange, fragmentary dreams, lacking connection to waking identity, dissolve more readily. Sleep spindles, brief bursts of brain activity during non-REM sleep, traditionally associated with memory consolidation of factual information, may also influence dream content and recall. Research has found that spindle activity correlates with dream reports upon awakening from non-REM sleep, challenging the notion that meaningful dreaming only occurs during REM periods. Spindles may support integration of recent experiences into existing knowledge structures, creating dreams that blend new and old information. These integration dreams, precisely because they're organizing meaningful recent experiences, might be more likely to persist into waking memory. Your brain creates different types of dreams during different sleep stages, with non-REM integration dreams potentially more memorable than pure REM narrative fantasies. The hippocampus, essential for forming new memories during wakefulness, shows complex activity patterns during sleep. During slow-wave sleep, It replays recent experiences to neocortical regions for long-term storage. During REM sleep, it exhibits different activity patterns, possibly related to memory integration and emotional processing. Dreams incorporating hippocampal-dependent spatial or episodic content. Dreams about places you've been, events you've experienced, may benefit from this specialized processing. These hippocampal dreams might embed more strongly in memory networks than purely imaginary dreams lacking grounding in actual experience. Your brain remembers dreams that continue processing real memories, allowing fantasy dreams to fade. Genetic factors influence sleep architecture and potentially dream recall, though specific genes remain under investigation. Twin studies suggest heritability for various sleep characteristics, including REM sleep duration, sleep depth, and even nightmare frequency. If these heritable sleep patterns influence dream recall, and evidence suggests they do, then your dream memory partly reflects genetic inheritance beyond conscious control. This genetic influence doesn't doom you to poor dream recall if you inherited less favorable sleep genes. Genes influence, but don't determine outcomes. Environmental factors, behaviors, and conscious practices still matter enormously. But recognizing genetic influence explains why some people naturally remember dreams easily, while others struggle despite similar effort. Some biological differences resist behavioral modification. The phenomenon of false awakenings, dreaming that you've woken up when you're still actually asleep, creates fascinating memory complications. People sometimes remember getting out of bed, starting morning routines, even having conversations, only to realize later these memories represent dreams of waking rather than actual waking. False awakening dreams blur the boundary between sleeping and waking consciousness, sometimes persisting as false waking memories. Your brain, creating elaborate simulations of awakening during dreams, demonstrates its remarkable capacity for generating convincing experiences. These false awakenings also reveal memory's constructive nature. Your brain fills gaps with plausible fabrications. Emotion regulation during sleep involves complex interactions between the amygdala and prefrontal cortex. Research from 2025 found that both slow-wave and REM sleep contribute to emotional memory consolidation through complementary mechanisms. Slow-wave sleep may transfer emotional memories to cortical regions, while REM sleep appears to strip away excessive emotional reactivity, allowing you to remember the event without re-experiencing full original intensity. Dreams play a role in this emotional processing. You might dream of threatening situations but wake feeling calmer, the emotional sting reduced through nocturnal processing. These therapeutic dreams, successfully processing difficult emotions, may not require preservation. Their healing work completed invisibly during sleep. You forget the dream but keep its emotional benefits. Chronotype, whether you're naturally an early bird or night owl, correlates with dream recall patterns. The 2025 research found that chronotype related to both dream recall frequency and vulnerability to cognitive interference. Evening-preferring individuals might experience more of their REM sleep during their optimal circadian periods, potentially enhancing dream intensity and memory. Morning-preferring individuals might wake naturally during REM periods, favoring recall. But individual variations dominate these general patterns. Your circadian preference subtly shapes dream recall. Though personal attitudes and behaviors matter more than whether you're naturally early rising or late sleeping, the relationship between physical exercise and sleep quality extends to dream recall. Regular exercises often report better sleep quality, which indirectly supports memory consolidation generally. But exercise timing matters. Vigorous activity close to bedtime can interfere with sleep onset and architecture, potentially reducing REM sleep and dream recall. Morning or afternoon exercise, conversely, promotes deeper, slow-wave sleep early in the night, allowing extended REM periods in morning hours. Optimal for dream memory. Exercise's benefits for dream recall likely work through improved overall sleep quality, reduced stress, and better emotional regulation, rather than through direct effects on dream generation. Physical health creates foundation for mental phenomena, including the delicate process of remembering dreams. Dream content varies across cultures, reflecting different waking experiences, beliefs, and concerns. But dream recall patterns show surprising cross-cultural consistency. Research across diverse populations finds similar recall frequencies, similar predictors of recall, similar age-related changes. This consistency suggests dream memory mechanisms reflect universal human neurobiology rather than cultural specifics. Your cultural background shapes what you dream, influences whether you value dreams, affects how you interpret dream experiences. But the fundamental processes determining whether dreams transfer from sleeping experience to waking memory operate similarly across humanity. Dream recall represents human cognitive architecture, not cultural construction. Nightmares present special cases of dream recall. People reliably remember nightmares far more than neutral dreams, often in vivid detail persisting years later. Emotional intensity, particularly fear and anxiety, creates powerful memory encoding. Nightmares frequently trigger sudden awakenings directly from REM sleep, catching the dream fresh and recent. The emotional arousal accompanying nightmares continues into waking, maintaining activation of neural systems supporting memory consolidation. Unfortunately, this means traumatic dreams persist while pleasant dreams fade. This appears to reflect ancient survival patterns. Your brain evolved to remember threats, even dream threats, better than neutral or positive experiences. Better to over-remember potential dangers than under-remember them. But it creates psychological burden when nightmares predominate over pleasant dreams in memory. Alcohol consumption before sleep dramatically impairs dream recall, despite initially promoting sleep onset. Alcohol suppresses REM sleep during the first half of the night, sometimes almost completely. Later, REM rebounds with unusual intensity, creating bizarre, fragmented dreams. But alcohol's lingering effects on hippocampal function and memory consolidation mean even these intense rebound dreams rarely survive to morning awareness. Drunk sleep isn't quality sleep. Drunk dreams, to the extent they occur, rarely reach waking memory. Regular alcohol use near bedtime sacrifices dream experiences and memory consolidation. Sleep disorders profoundly affect dream recall patterns. Sleep apnea, causing repeated breathing interruptions and awakenings, fragments sleep architecture and can reduce REM sleep, diminishing dream frequency and recall. Insomnia, particularly when characterized by shallow, disrupted sleep, might paradoxically increase dream recall through frequent awakenings, but reduce overall dream quality. Narcolepsy, involving dysregulated REM sleep that intrudes into wakefulness, creates vivid dreamlike hallucinations patients remember all too well. REM, behavior disorder, where muscle paralysis fails and people physically act out dreams, leads to memorable, often frightening dream recall. These disorders reveal how sleep architecture normally regulates dream experience and memory. When regulation fails, dream recall can become overwhelming or vanish entirely. The role of sleep in creativity extends to dream content. Many famous discoveries, artistic works, and problem solutions allegedly originated in dreams. Though skepticism about these accounts is warranted given memory's reconstructive nature, regardless of historical accuracy, laboratory research confirms that REM sleep enhances creative thinking, novel associations, and insight formation. Dreams may serve as creativity workshops, freely combining concepts impossible in waking logic. Creative breakthroughs occurring during dreams might be remembered precisely because they're creative, novel, surprising, emotionally salient. Your brain preserves dreams, offering useful insights while discarding repetitive, meaningless, nocturnal, mental wandering. Dream recall shows interesting developmental patterns across the lifespan. Young children often remember dreams vividly but describe them with simple, fragmented narratives. As language and memory systems mature through childhood, dreams become more story-like and socially complex. Dream recall typically peaks in young adulthood, when sleep is both abundant and easily disrupted, creating optimal conditions for memory formation. Later life often brings earlier bedtimes, more stable sleep patterns, and priorities shifting away from dream exploration. These changes reflect not cognitive decline, but evolving relationships with internal experience. The developmental trajectory mirrors broader changes in how consciousness engages with imagination, memory, and internal narrative throughout life. We've reached an important threshold in our journey. The patterns are clear. Dream recall emerges from your brain balancing competing demands. Sleep serves vital restorative functions, requiring deep unconsciousness. But consciousness never completely disappears. It transforms into dreaming, a strange hybrid state. Memory systems that evolved to preserve useful information struggle with dreams lacking obvious utility. Most dreams vanish because preserving them serves no adaptive purpose. The minority you remember represent exceptional cases. Dreams emotionally intense enough, bizarre enough, or meaningful enough to exceed the threshold for preservation. Your brain's default is forgetting dreams. Remembering requires either dreams worth remembering or conscious effort to override natural forgetting mechanisms. The phenomenon of recurring dreams reveals memory's role in dream formation. People experiencing recurring dreams report remembering them far more consistently than one-time dreams. This enhanced recall might reflect two factors. Repetition strengthens memory traces, and recurring dreams often address unresolved emotional issues demanding attention. Your brain may preserve recurring dreams specifically because they signal incomplete psychological processing. The recurrence itself becomes a flag indicating significance. These dreams repeat because earlier occurrences left issues unresolved. They're remembered because they repeat and because the underlying concerns remain salient. Dream memory and dream content influence each other in complex feedback loops. Sleep deprivation affects dream recall in counterintuitive ways. Missing sleep creates REM sleep debt that your brain will eventually repay. After sleep deprivation, REM sleep rebounds strongly. Longer duration, higher intensity. These REM rebounds produce exceptionally vivid dreams, often bizarre and emotionally intense. Some people remember these rebound dreams more reliably than normal dreams due to their unusual intensity. But sleep deprivation also impairs memory consolidation generally, potentially offsetting enhanced dream vividness. The net effect varies individually. Some sleep-deprived people remember more dreams, others fewer, depending on which factor dominates: increased dream intensity or decreased memory function. Lucid dreaming training techniques, developed over decades of research, consistently enhance general dream recall, even without achieving full lucidity. Practices like reality testing, frequently checking during wakefulness whether you're dreaming, train metacognitive awareness that carries into sleep. Mnemonic techniques like repeating, "I will remember my dreams before sleep," create intention setting that influences sleeping cognition. These practices work partly through enhancing motivation and attention toward dreams, signaling to your sleeping brain that dreams deserve encoding effort. But they also cultivate general metacognitive skills, awareness of awareness itself, that fundamentally alter consciousness. Enhanced metacognition during dreams strengthens memory formation. Lucid dreaming training teaches your sleeping mind to notice and encode experiences more effectively. The role of the temporoparietal junction in dream awareness has emerged from recent neuroscience research. This brain region, involved in perspective taking, sense of self, and distinguishing self from others, activates during lucid dreams, but not during ordinary dreams. This activation may support the metacognitive awareness defining lucidity, simultaneously experiencing and observing the dream. Enhanced temporoparietal activity during dreams might strengthen memory encoding by creating a more objective, observer-like relationship to dream content. Dreams you observe rather than simply experience may persist more reliably in memory, like watching a movie versus living an experience. Dream sharing, discussing dreams with others, paradoxically both preserves and distorts dream memories. Narrating dreams to friends, family, or therapists creates external memory storage and reinforces recall through retrieval practice. But each retelling subtly alters the memory. You emphasize certain details, minimize others, reorganize sequences for coherent narrative, unconsciously fill gaps with plausible confabulation. Over time, the shared version becomes the remembered version, potentially diverging significantly from the original experience. Cultural expectations about dreams influence how you frame and remember them. Dreams shared within communities, valuing dream significance, might be remembered differently than dreams within cultures, dismissing them as meaningless brain noise. Social context shapes individual memory. The relationship between language and dream recall reveals interesting cognitive patterns. Multilingual individuals sometimes dream in different languages depending on dream context and characters. Language availability during dreams might influence memory encoding. Dreams in your native language may be more easily recalled than dreams in secondary languages, possibly because native language processing is more automatic and less cognitively demanding. But this relationship remains understudied. Language serves as the primary tool for consciously encoding and recalling dreams. The linguistic resources available for describing dreams shape which dreams persist and how they're remembered. Modern sleep tracking technology and dream research apps create new possibilities for understanding dream recall patterns. Devices monitoring sleep stages can wake users during optimal windows for dream recall, typically during or immediately after REM periods. Apps prompting immediate dream recording upon waking reduce interference from waking activities. Some systems even detect REM sleep and play subtle audio cues designed to enhance lucidity without causing full awakening. These technological interventions show promise for enhancing dream recall, though they require balancing memory enhancement against sleep disruption. The ideal system would strengthen dream memory without compromising sleep quality. Finding this balance remains an active area of research and development. The concept of dream meaning influences dream recall in complex ways. People who believe dreams carry psychological significance, prophetic messages, or spiritual importance remember more dreams than those viewing dreams as random neural noise. This belief effect operates through multiple mechanisms: increased attention, stronger encoding intention, more frequent rehearsal, greater motivation to record dreams. But belief in dream meaning doesn't necessarily improve accuracy of dream memories. Enhanced recall might come with increased false memories, confabulation, and narrative reconstruction. Your interpretation of what dreams mean shapes how you remember them. Dreams aren't neutral data. They're interpreted experiences shaped by beliefs and expectations. Sleep positioning technology, from specialized pillows to adjustable beds, might influence dream quality and recall through effects on sleep depth and breathing. Better spinal alignment and reduced sleep apnea promote more stable, restorative sleep, potentially affecting REM sleep quality. But these effects are likely modest and highly individual. No pillow or mattress will dramatically transform dream recall. Comfort matters for sleep quality generally, which indirectly supports all cognitive functions, including memory. But dream recall improvements from sleep technology probably pale compared to behavioral changes like protecting morning waking moments from distraction or cultivating genuine interest in dream experiences. 3/4 through our exploration, the picture is complete. Remembering dreams better requires addressing multiple factors simultaneously. You need sleep architecture, favoring adequate REM sleep. You need cognitive habits supporting memory formation, mindfulness, reduced interference, protected morning moments. You need motivation and attention, genuine interest in dreams, belief they matter. You need appropriate behaviors, journaling, meditation, reality testing. No single factor determines success. A person with poor sleep architecture but strong motivation might remember more dreams than someone with excellent sleep but no interest. These factors interact, sometimes compensating for each other, sometimes amplifying each other's effects. Understanding the full system allows strategic intervention. You can't control every factor, but you can influence enough factors to meaningfully enhance dream recall. The question isn't whether you can remember dreams better. You can. The question is whether you care enough to try. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath. Inhale. Exhale. Inhale. exhale, a small cycle within vast rhythms. Sleep and wake, dream and forget, remember and reconstruct. Like tides advancing and retreating on ancient shores, like seasons turning through their eternal dance, like consciousness itself flowing between light and dark. You are part of these cycles, not separate from them. Dreams arise and dreams dissolve, all according to rhythms older than memory itself. You don't need to hold on to anything. Let everything unfold in its perfect order, like planets silently rotating in their orbits, unhurried, unresisting, simply existing. We're almost there now. Perhaps dreams aren't meant to be remembered. Perhaps their greatest gift comes through invisible processing during sleep, work that requires no conscious memory. Your brain clears toxins, consolidates learning, processes emotions, integrates experiences, all without requiring you to remember the dreams accompanying this work. Most dreams fulfill their purpose completely in the moment, then dissolve like waves returning to the ocean. The few dreams you remember might be exceptions, accidents, or signals of incomplete processing. Forgetting most dreams isn't failure. It's your brain working exactly as designed. The dreams you remember create a distorted sample of your dreaming life. You remember emotionally intense dreams, bizarre dreams, dreams from morning REM periods. But most dreams are mundane, continuation of waking concerns, processing of routine information, neutral mental activity. These forgettable dreams constitute the majority of dreaming, but leave no trace in memory. Your remembered dreams, though vivid and memorable, represent only the peaks of experience. Most dreaming happens in unremarkable valleys your waking mind never visits. The full landscape remains hidden. Memory and identity intertwine mysteriously. You are, in part, your memories. What you remember about yourself creates the story of who you are. But dream memories occupy strange territory in this identity construction. May dreams be part of you. Do forgotten dreams still shape consciousness? Questions without clear answers. Perhaps dreams contribute to identity below awareness, influencing mood, creativity, emotional processing without requiring conscious memory. You are more than you remember. Much of what makes you who you are operates invisibly. The sleeping brain creates entire worlds from memory fragments, emotions, random neural activations. These worlds feel utterly real while you're experiencing them, complete with sights, sounds, narratives, emotions. Then they vanish, leaving no evidence they ever existed except occasional fragments in morning memory. This capacity for world creation is remarkable. Your brain contains multitudes, infinite potential experiences, only a fraction ever recalled. Each night, universes bloom and dissolve in your sleeping mind, mostly unseen by waking consciousness. Recent research reveals sleep's role in forgetting to be as important as its role in remembering. Your brain can't preserve everything. It must selectively strengthen useful memories while actively weakening irrelevant information. Dreams, often lacking obvious relevance to waking goals, fall into this forgettable category. This selective forgetting isn't deficiency but sophisticated information management. Your consciousness would become cluttered, overwhelmed. If forced to remember every dream, forgetting clears space for what matters. The dreams you lose, Make room for what you need. Think about how much mental activity happens below awareness. Your heart beats, lungs breathe, body repairs itself, all without conscious attention. Most brain processing operates similarly, working silently to support consciousness without requiring conscious oversight. Dreams might function this way too, serving important purposes during sleep while requiring no conscious memory afterward. The value lies in the dreaming, not the remembering. Processing happens. Healing occurs. Integration completes. All invisible to waking awareness. All perfectly effective without memory. The boundary between sleeping and waking consciousness is more permeable than it seems. Daydreams resemble nighttime dreams in many ways. Internal simulations independent of immediate external input. Mind wandering during wakefulness accesses similar neural processes as nighttime dreaming. Perhaps consciousness exists on a spectrum from focused external attention through daydreaming to sleep, with dreaming representing extreme internal simulation. The dreams you remember might bridge this spectrum, existing at the intersection where sleeping internal simulation meets waking awareness. Memory itself is stranger than it appears. You think you remember the past, but you actually remember the last time you remembered. Memories of memories degrading and transforming with each recall. Original experiences are forever inaccessible, replaced by reconstructions based on fragments. Dream memories embody this uncertainty even more extremely. You remember not the dream itself, but your waking mind's interpretation of fragments surviving a neurochemical transition. The dream you recall might bear little resemblance to what actually occurred during sleep. Consider how dreams blend memory, imagination, emotion into seamless experiences. Past events merge with fantasized futures. Dead relatives converse with living friends. Impossible physics feel perfectly normal. This blending capacity represents your brain's fundamental creativity, its ability to recombine elements in novel ways. Whether you remember these creative products or not, the generative process itself exercises cognitive flexibility. Dreams might train creativity through practice rather than through conscious reflection afterward. The value lies in generation, not memory. Most of life happens once, then disappears. Conversations fade. Experiences blur into general impressions. Moments pass unremarked, forgotten immediately. Dreams simply represent extreme examples of this universal forgetting. The vast majority of your conscious experience, waking or sleeping, leaves no permanent trace. You exist primarily in the present, with only selective fragments preserved in memory. Dream amnesia isn't special. It's typical of consciousness generally. Most moments pass through awareness, leaving no footprint. The question how to remember dreams better assumes remembering dreams is inherently valuable. But perhaps the question itself deserves examination. Do you need to remember dreams? What benefits does dream recall provide? These questions may not have universal answers. For some people, dream memories enrich life, inspire creativity, provide psychological insights. For others, dreams remain private experiences sufficient unto themselves, requiring no conscious memory. There's no obligation to remember dreams, no deficiency in forgetting them. Your sleeping brain works tirelessly, clearing cellular waste, consolidating memories, processing emotions, integrating experiences, preparing you for tomorrow. This invisible labor benefits you profoundly whether you remember dreams or not. Sleep's restorative functions operate independently of dream recall. You wake refreshed, prepared, emotionally balanced, cognitively restored, all without remembering the dreams accompanying these processes. The work happens below consciousness, serving you silently. Maybe that's enough. Maybe dreams needn't survive into morning to fulfill their purpose. Think about how consciousness navigates between focus and flow. Sometimes intense concentration on tasks, sometimes relaxed internal wandering. Dreams might represent ultimate flow, consciousness, completely free from external demands, wandering wherever neural currents lead. This freedom is valuable precisely because it's unconstrained by logic or need to remember. The liberation lies in the wandering itself, not in keeping records of where consciousness traveled during its nighttime liberty. Freedom from memory allows freedom of exploration. Recent neuroscience reveals brain activity during sleep rivals waking complexity. Sleep isn't simply absence of wakefulness, but an alternative mode of consciousness, one prioritizing different functions, operating under different rules. Dreams represent this alternative consciousness at its most vivid. Whether you remember them or not, dreams reveal your brain's astonishing capacity for generating experience independent of external input. This capacity exists and operates nightly, accessible or hidden, remembered or forgotten, continuing regardless of conscious awareness. The answer to how to remember dreams better depends partly on why you're asking. If you seek insights, creativity, or self-understanding, dream recall might offer valuable resources. If you simply wonder what dreams contain, casual attention might satisfy curiosity. If dreams consistently fade before you capture them, techniques exist for enhancing recall. But if you sleep well and wake refreshed, dream amnesia might require no intervention. Sometimes, not remembering is perfectly fine. Your sleeping mind knows what it's doing. Consider the mystery of consciousness itself. You exist. You're aware. You experience. But how, why, these questions remain unanswered despite centuries of inquiry. Dreams deepen the mystery. Consciousness continues during sleep, generating experiences despite sensory disconnection from the world. The fact that you forget most dreams, perhaps, matters less than the astonishing reality that you dream at all. Consciousness creates worlds from nothing. This remains miraculous whether remembered or forgotten. Memory shapes identity, but forgotten experiences also shape who you become. A child's forgotten nightmare might leave subtle anxieties around darkness. A forgotten dream of flying might contribute to fascination with freedom. Experiences you don't consciously remember still influence neural development. Emotional patterns, behavioral tendencies. You are more than conscious memory contains. Forgotten dreams may live on in you, influencing mood and thought in ways too subtle to trace. The dreams you remember represent a tiny fraction of mental activity during sleep. Your brain processes, calculates, regulates, repairs, performing countless operations never reaching consciousness. Dreams you recall are simply the visible tip of massive unconscious activity. Perhaps this is how it should be. Consciousness focuses on a small subset of information relevant to immediate awareness. The vast majority of brain activity proceeds invisible, including most dreaming. This economy of awareness serves you well. Think about natural cycles of attention. Sometimes you focus outward on world and others. Sometimes you turn inward to thoughts and feelings. Sleep and dreams represent ultimate inward turn. Consciousness temporarily disconnected from external world, completely absorbed in internal simulation. Whether you later remember these inward journeys matters less than the fact that you take them. Regular oscillation between external and internal focus serves important functions. Dreams facilitate this oscillation whether remembered or not. Recent discoveries in sleep science reveal extraordinary complexity in how your brain processes information overnight. Multiple systems coordinate, consolidating memories, clearing waste, processing emotions, integrating experiences. Dreams accompany this processing, but may not require conscious memory to serve their functions. The sleeping brain knows its business, working with or without conscious oversight. Trust this ancient system. It evolved over millions of years to optimize both sleep's restorative functions and occasional dream memories deemed worth preserving. Your brain makes wise decisions. So, could you remember dreams better? Absolutely. Techniques exist. Strategies work. Practices help. Cultivate interest. Protect morning moments. Journal faithfully. Practice awareness. These approaches reliably enhance recall. But whether you should prioritize dream recall depends on personal values and goals. Dream memory isn't mandatory for healthy sleep or fulfilled life. Some people treasure dreams. Others let them dissolve peacefully. Both approaches are valid. Choose based on your own curiosity and needs. The real question isn't mechanical, how to remember, but philosophical. What relationship do you want with your dreaming mind? Do you wish to consciously engage with nighttime consciousness, or prefer letting sleep remain mysterious? Private. Separate from waking life. Neither choice is wrong. Both honor different aspects of human experience. Dream recall becomes possible through intention and practice. But intention itself is optional. The choice remains yours. Perhaps dreams offer a gift beyond memory. They prove consciousness continues without external input, demonstrating mind's capacity to generate experience from within. This generative power operates constantly below awareness. Imagining, simulating, creating. Dreams make this creativity visible, if only briefly. Whether you remember them or not, dreams testify to consciousness's fundamental nature. Not passive receiver of external information, but active creator of experience. This capacity deserves wonder. The boundary between remembered and forgotten dreams is thin, permeable, arbitrary. Small changes. Waking 5 minutes later. Experiencing slightly different neurochemistry. Avoiding morning distractions can shift which dreams survive. This arbitrariness suggests that dreams you forget aren't necessarily less valuable than dreams remembered. Timing and circumstance determine memory as much as dream quality. Some beautiful experiences vanish. Some mundane ones persist. Memory is capricious. We've journeyed through dream memory's landscape, from biology to behavior, from chemistry to consciousness, from forgetting to remembering. The truth is neither absolute remembering nor complete forgetting serves optimally. Your brain has evolved exquisite balance, preserving useful memories, discarding irrelevant information, protecting sleep quality. Most dreams vanish by design, clearing space for what matters. A few dreams persist, offering insights, creativity, emotional processing. This balance works beautifully without conscious intervention. Dream memory, like consciousness itself, remains mysterious, magical, mostly invisible. And maybe that's exactly perfect as it is. And so, our quiet journey through the science of dream memory comes to a gentle close. We've traveled from the neurochemistry that creates dreams to the morning moments where they dissolve, discovering along the way that remembering represents the exception, forgetting the rule. From sleeping brain activity to waking reconstruction, we've glimpsed how consciousness navigates between states, sometimes preserving midnight visions, usually letting them fade like mist in morning sun. Dream memory reminds us that most of life happens invisibly. Your sleeping brain works profound healing, processing, integration, all below conscious awareness. Dreams fulfill their purpose, whether remembered or forgotten. The sleeping mind demonstrates patience, working silently through darkness, asking nothing of waking consciousness, content to dissolve unremarked into morning light. In these final minutes, take the deepest breath you can. Think about consciousness itself. Yours, mine, everyone listening. All awareness, everywhere. Perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Every forgotten dream returns to the vast unconscious from which it emerged, joining countless other experiences living somewhere in neural networks you'll never consciously access. Nothing is truly lost. Everything remains part of the continuous stream of consciousness flowing through you. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. If this thoughtful exploration of the mind helped you relax or fall asleep tonight, a gentle like and subscribe helps other sleepless souls discover this peaceful space too. It only takes a moment, but it means the world to us. One quiet tap, one sleepy soul at a time. But there's no need to do anything now, nothing at all. You've traveled far tonight, exploring the hidden mechanisms of memory and dreaming. You can allow these thoughts to fade now, like morning mist dissolving in warm sunlight, leaving only peaceful calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity gently pulls you into the soft surface beneath you. If sleep comes, let it carry you like a river flowing inevitably toward the ocean, smoothly, naturally, into a realm where memory and forgetting no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, dreams will return. Your sleeping brain will create new midnight visions. Some you'll remember, most you'll forget. But tonight belongs to rest. Fall asleep to gentle facts. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.